you may know is that the defining condition of delta is precisely such a condition, and one of the cancellation conditions is this. So therefore G acts on CG.
Can we start?
Which one? Yes, of course, in the context of sister algebra, homomorphism means singular star. Okay. Now let us discuss the concept of the yes? Huh?
We're just muttering.
Okay. So the fixed point algebra of this action is given by so you collect all those elements in A such that tau A is of this form. So this is a subalgebra of A and you call it the fixed point subalgebra, and you say the action is harmonic if this subalgebra is nothing but scalars. Okay. Of course, these are analogs of a group acting on a space. Therefore, you can ask what will be the condition for an invariant measure. So, the state rho on A is an invariant state if this equation is satisfied, and you realize that this is proposition lemma is trivial if acts then there is a unique invariant state rho given by basically you realize that this element is in the, so this is in A tensor CG part is filled by A, so this is an element in A. You realize that this element is actually in the fixed point algebra, therefore it must be a scalar multiple of identity. You declare that scalar multiple to be rho.
Each of the
It is H. On CG part it is R. So this is nothing but a translation of the condition that for taking rho of A, you make your group element act on A and then you integrate, right? This is the projection onto the fixed point algebra. And precisely that is being done here. This entire thing is a translation of the classical argument, so nothing new. Nothing new.
So H is your
H is the hard state here. H is the hard state.
So you are taking A with the hard state.
No. It is a compact quantum group.
Okay.
Compact quantum group.
the exact same
It's hard state. Okay. So therefore, this hypothesis more or less settles our first problem, that if we restrict our attention to such systems, so we will call such a thing a system dynamical system. So a compact quantum group G acting on a
Unital C-star algebra A.
yes, acting on a sister algebra A. Unital sister algebra, sure. And for me, all the sister algebras are unital actually. On a unital sister algebra A will be called a sister dynamical system, and I will denote such a thing by A, G, and reaction tau. So if we have such a thing where the action is unpicked, then there is a unique invariant state, and so we can consider the representation, genus representation of A in that L2 space. So now we want to cut down the space of spectral triples.
So l3parth2, you take the GNS with respect to rho.
GNS with respect to rho.
What about faithfulness?
Faithfulness.
Rho won't be faithful in general.
No, for algebraic actions it will be faithful.
H itself isn't necessarily faithful.
See, there is a point is the following. So you are right in some sense not. So if I look at the reduced sister algebra associated with the compact quantum group, then it becomes so.
That's what you want to do.
Yeah, meaning
That's what you want to do.
those are part of hypothesis, otherwise I do not really bother.
About
All I need is really fixing a state. I never said that the pi should be faithful. So all I am really worried about is really fixing a state character. So simply do not bother. I never say that this whatever fixing the Hilbert space and the representation never demanded faithfulness of that representation. And in many occasions they won't be.
So you have the underlying Hopf algebra of the compact quantum group.
Yes.
Do you have an underlying nice subalgebra of necessarily of your A?
Yes, of course, because you have the spectral subspaces of A. So spectral subspaces will form an algebra. So there is a canonical dense subalgebra. There are more than one candidates depending upon the faithfulness of the R state. So if the R state is faithful, then both these candidates coincide. Otherwise, one can. I mean, there are two canonical choices, but they are not like there at this moment. So this is so. Now we want to pin down D. So I say a unitary representation U of G is solid of G in the Hilbert space. So in the Hilbert space, H is a unitary element U in the multiplier algebra of. I am sorry at this moment I do not quite elaborate upon the meaning of this, but when I come to a concrete problem, I will explain. This really won't matter. No, H is a Hilbert space. Now, this is a different definition, it has nothing to do with this. It is a different definition. I am defining what do we mean by saying a unitary representation of a compact quantum group. By a unitary representation of a compact quantum group, one means a unitary element like that will satisfy the following condition. So if I consider kind of take three legs of this operator here is
Yeah, what did you write? K0H.
K0H.
What is K0?
Sorry, cage, B0 cage, compact operators.
And M is the multiplier.
These are the compact operators, M is the multiplier. Sorry, yeah, cage, sorry.
Anyway, so you have a non-unitary system.
Huh?
You have a non-unitary system, right?
Yes, at this moment, yes. So, I take this operator U and I think of it as an element in the multiplier of this, which U12 is, sorry, no, this is wrong, please. 1 to 1 3 is the correct thing. Here I have done a mistake. Two of them are CGs. Yeah. So U12 is really this operator U acting on these two chunks and identity here. U13 is acting on this chunk and identity here. That is the meaning of this condition, 1, 2 and 1, 3. And such a condition is satisfied. Then we will call it a unitary representation. And if particularly for my research scholar friends, if you do not follow it, do not mind, we will come to a complete instance very soon. We will come to a complete instance. So, a coherent representation of a dynamical system. I said a dynamical system is given by this. So a coherent representation of this is a pair U, pi, where